Okay, let's get started with 1-5, linear inequalities. So we are going to learn some interval notation, which is probably new for us, and we'll solve linear inequalities and some applications. So we actually won't do the applications in this video, but we should know how to do them in class. We'll try those then. And we're not going to do that. We'll cross that out. And so we look at this as well. We'll understand that linear inequalities may have one, no, or an interval solution. All right, let's get started here. So you have seen something like this before. X is greater than 3 or x is less than 5, things like that. And you can actually do them in combination. So you could say x is bigger than 3, but also smaller than 5, right? So that's writing it here in inequality notation. There's something called set notation, which adds in this fancy x as a subset of all of this. If I ask for set notation, I'm okay with you giving me just this. You don't have to add in the fancy part. The new part now, though, is going to be interval notation, and that's going to be written with a and b, just the two numbers. We're not going to have to write the x in. All right, so that'll be new today, and then graphing, you have graphed on a number line before, so we'll get into that. One big thing to focus on today in this video is that when you multiply or divide by a negative number, you reverse the inequality sign. So if, let's say, negative 5x is greater than 15, when we divide by negative 5, and x is less than, reverse the inequality sign, negative 3. Okay, so let's dive in here. Just a reminder that interval notation looks like this. Let's see what that means. So x is greater than negative 3. We could write it as x is greater than negative 3. If we were to do this on a number line, okay, we could find negative 3. And you don't need to, for this class, start at 0 and go like that. Just represent negative 3 on the number line. Now, x is greater than, but not equal to, right? If it was equal to, we'd have the line underneath. So to do that, we can put an open circle. And if we're greater than, it's all of the numbers bigger than this. So you can either represent it as the squiggly line or as the arrow bar going this direction. Okay, so how do we write this in interval notation? In interval notation, we're going to say smallest number, comma, biggest number. Small, comma, big. Smallest number is negative 3. What's the biggest number if this goes on forever? The answer is infinity. All right. Now, if we touch, we're going to use a bracket. If not, we're going to use a parentheses. Are we touching negative 3? We are not. So we're going to say parentheses. Can you touch infinity? No. So we're going to say parentheses. So the interval notation for this is from negative 3 to infinity. All x can be anything in between. All right. So x is less than or equal to 5 would look like this. Here's how it is written out. So look at our graph first. We can use the bracket for touching. Right? You could also do this at 5 with a closed circle. I will accept that also. Going to the left. So what's the smallest number? Negative infinity. The biggest number is 5. And we're touching 5. So brackets. If we're in between negative 1 and 4, we're touching negative 1. So we get a bracket. We are not touching 4. So we get a parentheses. We are touching 0. So we get a bracket. The biggest number is 4, which we are touching. So we get a bracket. All right, so let's see if we can solve some of these things. So solving linear inequalities has a little explanation here. Let's just say it's exactly the same as solving equalities, okay? So on something like this, 3 parentheses x minus 16, we're going to distribute like we normally would. We're going to collect everything on the same side like we normally would, right? But then when we divide or multiply by negative, we switch the signs, right? So negative 5x less than x greater than. We multiply or divide, we switch the sign, the inequalities. All right, so an example. Let's see how we can do this. 5 minus 3x less than 23. Let's go ahead and subtract 5 first. Negative 3x less than 18. Let's divide by negative 3. X. We divided by a negative, switch the inequality. X is greater than negative 6. So this is our set notation. Our interval notation sometimes is easier to do after you graph. Once you do it a few times, you'll get the hang of it. Here's our graph. Going left and right forever. -6. Are we touching -6? No. Open circle. We're greater than. We're going to the right. So what's the smallest number? -6. Are we touching it? No. So parentheses. Comma. What's the biggest number? Goes on forever. So infinity. Are we touching it? Can't touch infinity. It's going to look just like that. And again, you can either do an open circle or you can do a parentheses on the number line. I'll accept either one. Your turn. Give it a shot. All right, if you did this correctly, 5 is less than or equal to 3 minus 2x. We're going to minus 3. And get 2 is less than or equal to -2x. We're going to divide by -2. And we will say -1. We divided by negative, so switch the signs. Greater than or equal to x. You're going to be making your life easier if you always write x first. So x is less than or equal to -1. So on your interval notation, since we do touch -1, we are less than it. The smallest number would be -infinity, and it goes all the way up to -1, which we touch, so bracket. Okay, solve the inequality. Just like a normal equality, we're going to multiply the denominators away. Multiply by 6. 6 divided by 3 is 2 times the 5x, less than. 6 divided by 2 is 3 times 4x, 10x, and are equal to 12 plus 9x. Subtract 9x, and x less than or equal to 12. Did we divide by a negative? No, so we did not switch the inequality. So on this one, we're less than, so the smallest number we would touch is -infinity. We'll go all the way up to 12, and we will touch it. Okay. So on this one, we could just write x is less than 12. That would be our interval notation, and if we did a graph of this, we would have 12. We would touch it, so close circle, and we're going less than. All right, another example for us, this one with double linear inequalities. So if x is in between, whatever we do to one side, we do to all sides. So in this problem, I want x by itself, and a -4. If I'm minusing 4 in the middle, I need to minus 4 to the left and to the right, all sides. The -6 is less than 3x, is less than or equal to 12. Let's divide by 3 to get rid of the 3. Divide everything by 3. So -2 is less than x, less than or equal to 4. All right? So what's our smallest number? -2. What's our biggest number? 4. I can't touch the -2 because there's no equal to here, but I can touch the 4 because it has the equal. Okay? And on the graph, it would look like this. -2, open circle, 4, closed circle, shade in between them. Okay? All right, one more example. Let's get rid of our denominator. We need to multiply by 7 everywhere. So these 7s cancel out. 7 times 1 is 7. -2 minus 3x less than 4 times 7 is 28. Let's add 2. We'll get 9 is less than or equal to -3x is less than 30. Divided by -3. So this is -3. We divided by a negative, switch your inequalities. 30 divided by -3 is -10. Switch your inequalities. And you always want to write this from the smallest number to the biggest number. -3 is bigger than -10. We're not touching -10. We are touching -3. Okay? Graph would look like this. One more example for us. Okay, on this one, we have x in all sorts of places, but let's solve this like we normally would. We would say minus x minus x minus x. Those x's go away. We have -1 less than or equal to 3x minus 4 less than or equal to, those cancel out, 8. Now let's get x by itself in here. 4. So we would have 3 less than or equal to 3x. Let's cancel out. So 12. So we would have 1 less than or equal to x less than or equal to 4. We're in between 1 and 4, and we're touching both of them. All right, your turn. Give this a shot. If you did this correctly, we're going to subtract 2x first. And so we'll get 1 less than 2x plus 2 is less than 5. We'll subtract 2 everywhere. Negative 1 is less than 2x less than 3. Divide everything by 2. So negative 1/2 is less than x, less than 3 over 2. Integral notation, negative 1/2, comma, 3/2, and sorry, parentheses on both. All right, we'll see you in class next time.